Question 11f. Evaluate the definite integral from x equals negative 3 to x equals 0 of x over the square root of 1 minus x dx using the substitution u equals 1 minus x. Starting with the substitution u equals 1 minus x, I'm going to rearrange it to make x the subject. So we have x equals 1 minus u. Differentiating u with respect to x, we get du dx equals negative 1. Multiplying both sides of this equation by the differential dx, we get du equals negative dx, or dx equals negative du. Next, we need to change the limits of integration in terms of u. So when x equals negative 3, u equals 1 minus negative 3, hence u equals 4. And when x equals 0, u equals 1 minus 0, hence u equals 1. So the integral from x equals negative 3 to x equals 0 of x over the square root of 1 minus x dx is equal to negative the integral from u equals 4, u equals 1 of 1 minus u over the square root of u du. So x has been replaced with 1 minus u, and the square root of 1 minus x has been replaced with the square root of u. Now the negative sign in front of the integral can be cancelled by reversing the limits of integration. So this negative integral from u equals 4 to 1 is equal to the positive integral from u equals 1 to 4. I've also split up this fraction, so I've expressed it as a difference of two fractions. So this integral here now is equal to the integral from u equals 1 to 4 of 1 over the square root of u minus u over the square root of u du. And expressing the surds in index form, that equals the integral from u equals 1 to u equals 4 of u to the power of negative half minus u to the power of half du. So after integration, we get 2 times u to the power of half minus 2 over 3 times u to the power of 3 over 2 from u equals 1 to u equals 4. Applying the limits of integration, we get negative 4 over 3 minus 4 over 3, which equals negative 8 over 3, or negative 2 2/3.